Hello everybody, welcome to the Tabs and Safe lecture. After from finishing modeling the structure, we can now begin to run the analysis. To run the analysis, we go to run analysis. But before from running, we must go to analysis, set load cases to run. We must check here the calculate diaphragm center of mass and center of rigidity. Because we need to calculate the percentage between center of mass and center of rigidity. If we not check this option, the ETABS cannot calculate the percentage between center of mass and center of rigidity. We can press now, so we can now press run now, or we can press OK, then run from here. So now ETABS began to do the calculation. Now ETABS has finishing from calculation. We can show here the deflection and displacement due to loads. The deflection here and displacement is not important because we will check them after and the next lecture. First of all, now we will check the percentage between the center of mass and center of rigidity. To do this thing, we go to display show tables. So display show tables, we go to analysis, result, structure result, center of mass and rigidity. We press OK. We have two tables. So then we go to this Excel sheet that is included with the course and the first session with the PowerPoint and AutoCAD file. We go to ETABS and we select this copy. These are the coordinate of the center of mass and the X direction. We select all this coordinate, then right click copy and we paste them here. Then same thing for Y direction. We select them all and we paste them and their place. Then we go to the coordinates for center of rigidity and direction X and we paste here. Then we go for Y direction and we paste them here. So this Excel sheet help us to calculate and to check the percentage of center of mass and center of rigidity. This Excel sheet do the calculation and this way. Here we have the center of mass, the coordinate of the center of mass and the X direction, and here we have the coordinate of the center of rigidity and the X direction. If we do this number minus this number, we get the distance between the center of mass and center of rigidity and the X direction. Then we divide the number by Lx, then we multiply it by 100, we get the percentage between center of mass and center of rigidity along X direction. The same thing in Y direction and the same thing for all stories. We note here first of all that we have 2%, but the ACI code, as we said before, take 5% the minimum percentage between center of mass, center of rigidity, even that we have 2 or 1 or 3. Also, we note here that we have a percentage above 20%. So we are in the case and the dynamic case. So we are in the right way when we define the dynamic loads. For this thing, we define the dynamic loads. Now we have learned how to show the percentage between center of mass and center of rigidity. Thank you for listening. We will continue in the next lecture.